Okay, everybody, welcome to my presentation. It's going to be about large projects. I'm Szczepan, and I hope I can deliver all the contents that I want to say, because I'm going to touch on the configuration things, and I'm going to touch on some of the stuff that Hans has been talking during his keynote about the things that we plan. So there's a lot of stuff. We have only 90 minutes. I'm going to do some demos. So hopefully it's going to be all good, and we're going to meet that. Anyone uses Mockito? Couple of people. Anyone uses JMock? Mockito. Oof. Nobody uses JMock? Yeah? Oh, no. Oh, okay. We'll talk after the... Okay. So, first question is, how big is your project, guys? Anyone wants to share? Anyone has a 1,000 plus sub-module build? Oh, nice. More than 2,000? No. Okay. So, more like 500 modules? A little bit. Okay. So I guess not so gigantic. At LinkedIn, that we support, there's a 4,000 module build, which is very interesting. LinkedIn presses hard Gradle to scale and to be smart about doing things in a performant way. So some of the things I discuss here are the things that came up from the use cases found at LinkedIn. So let's move on. The problem with large projects is that every kind of small problem becomes big in large project. If you have a Hello World application and you have some small problem with that, you're going to immediately find the reason. In large projects, there are so many things that can go wrong. Come again? Sorry. There are so many things that can go wrong that sometimes we waste hours on figuring out simple things. Everyone was there, right? And there's also a problem with legacy code, right? So large project inherently has more legacy code. Every project has legacy code at some point. I hope you are not there, but there are even some teams that write legacy code on a daily basis, even though legacy code is an old code that wasn't maintained very well. So how come the new code is legacy? But hey, my idea for legacy for big project is to not have them. So avoid large projects, do microservices, be small, and everyone will be happy. One of the small problems that can be big in larger projects is problems with using a wrong version of something. It's a timeless problem. It has always been there, like wrong version of some dependency, wrong version of a build tool. I have a friend, his name is Igor, and he was a legend in my company, the previous company I worked for, because he used to solve problems very easily where some people were wasting hours. I was a witness of one such situation. Some developers the build was not working. It was Maven, but I have nothing against Maven. Maven is beautiful. So, and the problem was that it builds on one machine, but doesn't build on the other. And the revision is exactly the same. The guys are spending time figuring out. They checked out exactly the same directory on their Windowses. They used Windows. It still didn't work. They came to Igor and they started explaining the problem. Hey Igor, can you help us? We've checked in exactly the same revision. It builds on that box and it doesn't build on. And Igor didn't let them finish. He just said, check Maven version. They've checked Maven version. There was a slightly different Maven version. That's why the build didn't work. And so these days you have some ways to enforce the version of Maven. But what I really like about Gradle is Gradle has the wrapper. And Gradle, hang on, that's too fast. Let's talk about wrapper. So, and Gradle had wrapper a long time ago. So even before I started Gradle, there was a wrapper. And that was the thing I really loved about Gradle, that this problem, a consistent version of a build tool that is used in your team has been solved by the wrapper. And I remember back in the days, wrapper was promoted as a tool that helps you download Gradle automatically, magically. You don't have to have Gradle downloaded to invoke Gradle build. And I was never sold to that feature of the wrapper. For me, the most important thing about the wrapper is that there's consistent version used in my team. And this is what I love most. And I really like the fact that Gradle has solved that 5 years ago. And it's the standard. Every one of you, I'm sure, uses the wrapper. If not, we'll talk later. But that's the wrapper. Another thing that we want to avoid in very large projects is any kind of wasted time. In small projects, when there's some inefficiency that costs seconds, it's fairly cheap, but it magnifies in large project. Seconds wasted in a small project, in a large project, they become minutes and hours. So therefore, in Gradle, you want to use the daemon. Who uses the daemon in Gradle? Not so many hands. I should see more. Oh, thank you, guys. Daemon. Traditionally, when you invoke Gradle, JVM process is starting. Java runtime is loaded, Groovy runtime is loaded, the build is executed. And at the end of the build, you see beautiful build successful, or not so beautiful build failed, and the JVM exits. With the daemon, the JVM sticks a bit longer, and it gives us an excellent opportunity to do something interesting, because we have a long-living process that stays there. It can do very interesting things. It can do caching. It can do some preemptive stuff, so that next time you run the build, things are faster. In future, well, the daemon can predict what you want to do. And when you run the build, build successful, 0 seconds. How come it's 0 seconds? But because the daemon knew that, you have changed your Java code and your test. You probably want to ensure that you will probably compile that code. You probably want to run this test. You probably want to do a static analysis check style, for example, on that code. So the daemon can do that for you. And then when you run the build, it's already there. The information is already there. So that's a song of future. The daemon will get smarter, will get better. Currently, it does not do so many fancy things. But still, it's cool that it avoids you loading the Java and Groovy runtime, so you don't pay the cost of that. The builds are snappier, so definitely use the daemon. And the next thing I want to discuss is building the model. So often at our presentations, we hear about the build model and building the model. So what's going on here? So let me just go historically back to the end. Anyone uses and these days still? Oh. Whoa, so many hands, beautiful. This is a nice migration story I can see. So in AND, you don't really have the build model. So the build model is kind of an esoteric definition what it is. So what I mean by the build model is that in AND, when the build is executed, basically every instruction is executed one by line. So even though AND uses XML, declarative language, it's still sort of imperative script that is just executed one by one. So it's a script. Now, so there's no model. It's just stuff is executed as it goes. And now consider Maven or Gradle. So when you invoke Maven build, before any goals are executed, the entire model of the build is loaded. So all the projects are loaded, all the goals are loaded, all the stuff is loaded to the memory. Same like Gradle. So when you execute any Gradle build, first thing that happens, Gradle configures everything, entire world, all the projects, all the tasks, all the configurations, all the dependencies, right? It does not download dependencies, it configures things. So that's the first thing that's happening. It's building the model, is this configuration. And the bigger your project is, the longer it takes to configure, and the more it consumes memory. So every build tool that has model, like Maven or Gradle, may have problems with scalability once your project number grows beyond certain number. So we do builds that consist of 1,000 sub-projects in Gradle, but who knows how it deal with 100,000 projects, whether it would work nicely. Hopefully, nobody will be in that situation. So the configuration time. Before I jump into discussing more about configuration in Gradle, I just want to tell you that from my experience after several years with Gradle, that there are exactly two fundamental concepts that you need to grasp to be proficient with Gradle. First thing, something that I'm not going to dive too deeply into in that talk, is mapping of the DSL to the Java code. So that's absolutely critical. When you understand that, you're halfway through to be an expert in Gradle. A second thing is grasping the configuration versus execution phase in Gradle. So this is what I'm going to drill into now. So with each invocation of Gradle, traditionally, Gradle does configure everything, all the projects. Now, this does not really scale well if you have 1,000+ projects, because not necessarily you want to, you need to configure everything to do something in your build. You might be working in the small subset of projects, for example. Let me do the demo, actually. So in Gradle, we have a performance project that has some scripts that allows us to generate some sample projects. Let's actually use one of that. So I'm going to go to the Gradle source. We have a performance sub-project. I'm going to just print tasks that we have there. So as you can see, even when I build Gradle, you see this configuring project phase. So let me just put the font a little bit bigger so that it's better seen. But anyhow, I printed the task of the performance sub-project. And I have the project setup tasks. And I'm going to generate a multi-project build. Performance. I'm generating that. Again, you see configuring projects. So first, the configuration phase. We configure everything. Then Gradle figures out what to do. And then the build gets executed. Now, I've generated that project. And this is the project that I'm going to be doing demos right now. So let's cd into that directory. OK. Now, what I'm going to do is I'm going to build it. Now, before that presentation, I have been building that project. So it might be, building it might be not so slow because Gradle has cached the, oh no, it didn't cache. So as you can see, the Gradle is configuring 100 projects now because this build is generated for 100 projects. And you see this message compiling script into cache. Gradle build scripts are groovy. OK? All right, sure. So let's stop it. Let's run the build again. Since I'm doing it the second time, configuration will be faster, but it's tangible. You can even count that it's happening. It takes some seconds, right? We want that to be really, really fast and snappy. Now, in 100 project build, you can actually see that is really happening. In a very small projects, people are not aware about this configuration execution. It just runs, and everyone is happy. And let me force rebuilding of the caches because I wanted to show that. So I'm going to specify a different Gradle home directory. Gradle home directory is the dir where Gradle stores the dependencies and cache scripts and various things. So I'm going to just do tmp3 because it doesn't matter. So if I've chosen a different Gradle home directory, we should see that the configuration is slower because Gradle has to compile each of the build scripts. Build scripts are groovy. We need to compile them. So whenever you change the build script and you run the build again, Gradle will have to recompile that script. But if you don't change them, Gradle will use the cached copy from the Gradle user home, and the configuration will be faster. But I wanted to tell you that, in very large projects, many sub-projects, what's happening is that you can see that when you change the Gradle version, upgrade to a new Gradle version, you're going to see that this phase of compiling those build script can be sort of tangible, and you can see that it takes minutes, for example. Okay. So that was a demo of the configuration, how it works. Now, any questions by now about that? No. Okay. Let's move on. So first thing we've introduced to tackle some of the problems with the long configuration is that we introduced configuration on demand mode. Let me show you an example of that. I'm going to cd into one of the, actually, let me just move that here so that it looks better. Okay. Oh, that's fine. Okay. I'm going to cd into one of the sub-projects. Let's cd into project 34, let's say. And I'm going to do Gradle build. So I'm building only project 34 now. So Gradle still configures all the projects, even though I'm building only project 34. If we take a look into the build script of project 34, hang on, let me just not drop the text. It's fairly small, but it's isolated. This project does not depend on any other projects. If you look at the dependencies section, we only have jar dependencies that are resolved from the repository. This project is completely isolated from other projects. And even though it's isolated, where are we? Here. Even though it's isolated, Gradle still configures every single project to run it. There is a clear inefficiency here. Why do we need to configure all that projects, right? Therefore, configuration on demand mode is introduced. So this before GC, after GC stuff is because our infrastructure for generating the project templates has this code here. I'm going to remove that so that the view is cleaner. And before I demo the configuration on demand mode, I want to introduce something to the root build script file. So all projects, so for all projects, I'm going to create, after evaluate hook, that just print lines configured it. Print line that given project have been configured. And if I do Gradle build again without configuration on demand standard mode, whoops, after evaluate, thank you. Beautiful. So you can see configured project. All those projects has been configured. Now let's run with configuration on demand mode. It's much faster. It's less than 1 second towards 3 seconds. And as we can see, there's a root project configured, and there's a configured project, project 34. I'm going to explain later why we still configure the root project, even in configuration on demand mode, which is pretty nice. Now, I have a question for you. If I have a dependency in my project to a different project, compile, project 35, okay? What's going to happen in configure on demand mode if I build the project 34? It now depends on project 35. It's a compiled dependency. So we want to put the publications of the project 35, a jar, on the compiled class path of the project 34. If I run in configuration on demand mode, can you tell me what projects will be configured? Come again? All of them? It's a configuration on demand, so I hope it's smart enough to configure only the stuff that is needed. And since in theory we need only 34 and 35, let's take a look. So root project multi has been configured, 34 and 35. So Gradle understands those project dependencies, configure on demand understands them, and is able to figure out what needs to be configured to execute the build reliably. Yeah? So once we have that, I have another quiz for you. Let's say I have a task here. Hello, Kali. Do last. Hello. Now, if I do Gradle hello, Kali, can you tell me what projects will be configured in that mode? Which one? The project that has this task for sure, project 34. Anything else? What about 35? Will be configured?
34 depends on 35.
Yeah, you think so? Okay.
To config on demand, so it's going to be all again?
Oh, yeah, all of them. I'm missing that. Thank you for that. You're right. No, this is the right question now. Configure on demand. And that was your, okay, gotcha. So, question, whether the project 35 will be configured in that mode right now. We are running Hello California. Yes, no? Should not. Yeah, should not. If it's smart, it should not. Because project 35, and it isn't. 34 and multi, honestly. Because we depend on project 35, but Gradle understands the essence of this dependency is that we want to have the project 35 on compiled class path, right? And we are not resolving compiled class path to print the hello message, right? So configure on demand mode understands that and respects that. Now, one thing that it also, okay, let me change that a little bit and have another question for you. I'm going to add it depends on 35 build. So I've created a dependency on a task from a different project. So I'm using the fully qualified path to the task. So I'm qualified the task name via the qualified path of the project. So with the colon, it's all good. Now, when I run hello Kali with configure on demand, which project will 35 will be configured? Yes, no? Yes, okay, cool. Let's try it. It has been configured and it has been executed. So that's another thing that configure on demand supports. You can have qualified dependencies on the task to different projects. This feature might change, but more about that on the Adam's talk about new features in. Yep.
What if you do something like in your do last, walk the dependency tree?
Walk the dependency tree. Oh.
Yeah, like print off all the dependencies, like grab all the dependencies.
Of that project or a different project?
For that project. But
It will be resolved. Oh, yeah, good point. So I'm going to do, to explain that, I'm going to run the standard dependencies task, okay? So I'm going to do dependencies for configuration compile. So this is going to print as dependencies, but it's going to also resolve them. That was your question. You know whether or not?
But if you did that, so instead of doing dependencies, if you would walk the dependency tree, like grab the dependencies in your do last, because because Gradle, I believe Gradle doesn't have visibility at that point.
Mm-hmm. Let's do
So I
that.
was just wondering if it would.
Let's try. Gradle, don't fail me. No, I'm sure it works. It's just I want to show you, okay? Configurations, compile, each, print line, it, name, okay? And I'm going to use abbreviations for running the tasks to show dependencies. There you go. So we have those dependencies here. As you can see, we have project 35 at the top.
Oh, it does. Wow, that's cool.
So how far are we? Like 25 minutes through the Come again?
I said it only configures the execution time.
Yes. Yes. Which I'm not sure if is desired. If I look at the grand plan, like this configuration here. So I'm going to talk about the because that's actually an interesting thing that you touched, that it's configured there where execution has already started, right? So it's where the configuration execution phase overlaps. And I'm going to discuss that in further details when we go to the configuration model. But that's interesting. So interesting feature of configuration on demand. So, any questions about that? Yeah?
Maybe somewhat related. What happens if the root project has a sub-project block?
Good question. So in general, we always configure root project at the moment in configuration on demand mode. Just because typically people use sub-projects in the root project to avoid duplication. And we want to support that use case. Down the road, we're going to fix that, and we're going to offer clean ways to reduce this duplication. For example, we could use settings.gradle for that, because that's kind of a setting if this is for all projects. So that we don't have to have that sort of artificial thing that root project is always configured in configuration on demand mode. But right now we have, and it works well enough. It's just one project that is extra configured, so it does not really does a lot of overlap and a lot of performance bottlenecks. So yeah, does it answer the question?
Though, would the sub-projects block imply configuring all the other projects?
It will. That's the limitation. I'm going to talk about that later. Okay. So another task I have, you guys, and I'm going to show you a feature of Gradle, which is not very nice, I have to confess. Show depths. Let's do show depths, but let's do it like that. So I'm going to remove. Actually, let's reuse the existing task. So I'm going to do something like that, but project. How do I get rid of that? Oh, come on. Sorry, guys. Maybe let's do this. Okay, so my show dependencies task now reaches out to the project 35. Just, you know, there's brute force. Just give me stuff from that other project. In Gradle, in theory, you can reach out to any parts of the model from any project. It's a great liability, and you know, it's a powerful feature. Don't use that. It's only for us experts, and because there are clean and legal ways, legal in terms of decoupled projects, which I will discuss soon. It's not a very clean way of coupling projects. Clean way of coupling projects is dependencies. I depend. It's very declarative, and it allows Gradle to figure stuff out to make Gradle smarter. Now, this is directly accessing the model of a different project is sort of a hack. It looks bad here because I want it to look bad. Don't do it. Let me show you how it works. I'm going to run show deps without configuration on demand mode. So it configured all the projects, and it showed us the jar dependencies. Now, it worked because during the configuration, Gradle loaded and configured all the projects. Now I have a question to you guys. What will happen if I do that with configuration on demand mode? Configure on demand. What dependencies will be printed? Let's see. Whoa! Oh, nice error. Could not find property compile on configuration container. What's happening is that compile configuration was not found in the configurations of the project 35 because project 35 was not configured when show deps task was executed. It shows that you can't have those couplings like that. You can't reach out to other projects' model if you want to use configuration on demand mode. Don't do that. There are clean ways to couple projects together, and there are solutions to all known use cases without using those kind of hacks. And this is looking bad, but you can have things like sub-projects. Given that this is not a root project, this is some project in your graph of projects, you can have a sub-project close here, and then let's say plugins with type Java plugin, and then let's say configure source compatibility equals, let's say 1.7. Now this does not look hacky, this looks nice, you know, all the Java sub-projects configure this kind of source compatibility. But now in the world of decoupled projects, in the world of configure on demand, and all the next things we plan for configuration model, this is not acceptable. You don't want to reach out to sub-projects to configure things there. We will provide ways to reduce boilerplate and duplication so that you can smartly configure a set of projects to use given source compatibility, but it's not going to be that this way. Because what's happening here is basically Gradle iterates all the projects and adds this action that will get executed for every sub-project. Anyhow, any questions for now for the things we've discussed? Yeah?
So if that's not going to be acceptable going forward, will sub-projects and child projects, will all those things be deprecated then? When the new
Yes. So it sounds scary if I say, wow, this is unacceptable and stuff like that. Don't get scared. It's a long way to incrementally change the configuration model. We will provide ways to deal with those use cases as we go. Because those are important use cases, like configure source compatibility for source set of projects. I mean, we have to respect that. So we will provide ways, clean ways to do that without using constructs like that. Yeah? Okay.
The with type is a dynamic filter anyway, so it doesn't.
It is yeah. So it's fairly mild problem here because with type is a dynamic filter, right? So it's yeah, it's not too bad. I could come up with a maybe better example. Good point. Okay. So question: do you know? Hans actually told that on the keynote. What's the desired effective configuration time we aim for? 0. Hans told that. He broke my presentation. Okay, so to sort of grasp configuration on demand, I need to introduce the concept of decoupled project. Configuration on demand requires decoupled projects, with the exception of root project. In the configuration on demand mode, we configure the root project always. We configure the project where you execute the build. If you cd it in some directory where the project lives, we're going to configure that project as well. And then we're going to follow the dependencies and configure other project as needed, as they are, as we demand them. Yeah. So configuration on demand mode is just the beginning for more interesting stuff we plan for the configuration changes. The more on that is there's a design spec, project configuration model. I think Luke will work on that. I hope. You're going to work on the configuration? Beautiful, because Luke is very effective. A few weeks ago, I didn't know about plugin portal. Now I go to presentation. It's so beautiful and working, so yeah. Okay, let me go briefly through the configuration model changes that we plan. And because Adam tomorrow has a session on that, he has a larger brain than mine, so if ask him questions about those things. I'm going to just tease you with some of the things. Okay, so we're going to improve the configuration on demand mode. So we're going to build the model selectively, only the stuff of the model that are needed we're going to build. And because the current problem with configuration on demand mode are that we still instantiate all those projects and they are pretty heavyweight. So in LinkedIn build, 4,000 projects are instantiated even if only a single project is needed for the build. We don't want to configure projects. So another question was about sub-projects. So if in my root project, I have an old project close, even if I use configuration on demand mode, this after evaluate action will be added to every project. So it's sort of inefficient. I'm running the build within a single project. I'm using configuration on demand mode. I expect that Gradle to be smart and after evaluate action to be applied to only a single project. Now what's going to happen is the action will be added to every single project, but obviously only the projects that are configured will trigger the action. But still, you see that there's something that we can improve here. So let's take a look. What are other things? Oh yeah, the nirvana, parallel and distributed execution. So we now have a parallel build. I'm going to demo that later. So it's a current parallelism that we support is based on threads. But as we go further, we will be able to execute in separate processes. And once we have that, we can distribute across machines and run the build on the different boxes. So the configuration model changes will enable that. Other things that are going to be useful. So we'll be able to sort of blur this distinction between the configuration phase and execution phase. The configuration of project A can be run in parallel with execution of project B because there are no dependencies with them. So we won't have this distinction phase that first configure and then execute, right? Another thing is that the projects can be configured in parallel. This is the feature we don't have right now. So even if you use parallel build in Gradle these days, the configuration is still sequential. So it still is single-threadedly runs, configures all the projects. Any questions for that? Please no. Okay, go. Okay. Oh, we're going to push the input-output abstraction further. So right now, only tasks have inputs and outputs in Gradle, but it doesn't have to be like that. We will make projects declare inputs and outputs. What it means is that the incremental build will be on the more coarse-grained level. It's going to be faster. Imagine 4,000 project build. Every project has, let's say, 30 tasks. So you have hundreds of thousands of tasks, possibly. If you run the incremental build, calculating the inputs and outputs of every single of the task, given that the task amounts is 100,000, it's going to take time. Where if we have inputs and outputs on the higher level, on the project level, we're going to narrow that down. We're going to go faster. Right? Another thing is that we can introduce the concept of inputs and outputs on configuration. So the configuration of things will be consisting of the, so like, because consider configuration of a single project. It has inputs and outputs. Input to a configuration of the project is the build.gradle file, is the build script class path, yeah? So in theory, Gradle could consider configuration of a single project up to date, right? The build file hasn't changed. You don't configure that project. Use the cached value of that project, yeah?
Will you expand the concept of at least inputs to include, say, property settings?
Property settings?
Yeah.
So the question was whether we want to include the property settings for, we want to expand inputs and outputs to also support properties? Like, not sure I understand. So right now when you have inputs and outputs for a task, you can configure that this task has this input property and it can be completely a string or some value.
Well, let's say you set some property to be some value on the command line. Well, that...
Oh, you mean minus p?
Yes. That setting can affect the output of the build.
Yes. So it has to be an input as well. Everything that can impact the model has to be an input, and yes, properties have to be an input. So there are many things we have to figure out, because in theory, the tasks you have selected for the build is also kind of an input for the model, right? Because you could have a code in your build script that if this task is requested, you know, I don't know, configure this, configure extra task, for example. So in theory, there are many inputs to the model, and we will have to figure out some ways to tackle that challenge. But we will figure that out. Yeah. Adam will figure that out. So it's all good. So if you consider, if we can break down configuration into configuration actions that have inputs and outputs, we will know whether we don't have to configure something because it's already configured, it's already up to date. Another cool thing is that we will understand who configures what if we further drive this concept. It means that right now in Gradle, let's take a look at one of the files. Let's say project 3. So when you apply some plugins, they add tasks and configurations, right? But some other plugins can add more tasks, or they can configure existing tasks. And you don't really know who configured what. You don't really know where given tasks come from, which plugin. And sometimes this is painful because okay, this task is doing that. Why is it doing that? You know, I'm applying this plugin. Normally, this plugin is only it configures this task to do this, but this task does some extra stuff. And you have to figure that out. Maybe there is some other plugin that added a do last action to that task, and how do you know that? Yeah, so if we push further the configuration, we're going to make it possible to understand those things. We will know who configures what and when. We're going to fully control the configuration. Make sense? Yep.
Does the Gradle daemon reinstantiate the project configuration when you run a build again, or can it reuse the classes?
Good question. So right now, the daemon does not cache the configured model, but it will. So that's one of the things we want to have. It's like many times you don't change the build.gradle files, right? You don't change the model, or at least you don't change the entire model. You change the Java code, for example, typically, right? And when you run the build, it would be nice if the daemon contained all that model in memory, right? So that's one of the things we want to have for this zero configuration time sort of goal. So yes, it will have that in future. So, and then it needs to be smart, right? It needs to know when to invalidate the model, right? So that when you change the build script, Gradle has to know that he needs to rebuild the model for that project. So, but that will happen once we get our hands properly on that. This is the stuff that I'm talking about, these changes in the configuration, they are already happening. So this is not like a song for 2016. This is stuff that is happening on master as we talk. Maybe not as we talk, but shortly before conference. We laid some cornerstones for that when we did the native, integration, native plugins. So it's happening. So there are a bunch of other features that we want to plan with that configuration model changes. We want to, for example, have a fast command line completion. When you type Gradle and you type a little bit of the task name and then hit tab, let's say, and it tells you what are the tasks available, those kind of things. But there's a lot of stuff. So before we get there, we need a decoupled model. So decoupled model in general is that configuration of the project cannot refer to the domain object or state outside of that project. And configuration also includes the plugins that you apply, which means that if we are in that mode, in that world, where we have decoupled projects, the plugins that you apply also need to conform to that. We will be getting there incrementally, so we'll be adding validation and things. I don't want to drive into like an implementation plan for that, but just keep in mind that this is happening. Things that you can't do if you want to keep your projects decoupled. So don't use root project, don't use parent project, don't use all projects. Those are the things. Obviously, there are good reasons these days to use those things, but we will offer solutions for the use cases that require using this API. So the supported project relationships, this is, so what I'm talking about now, this is the future. Those are the model changes. So this is not what's currently in the code base in the Gradle master. So basically, projects will declare the publications, and those publications can be consumed by other projects. Okay. Okay. So before we get there, before we have all that configuration stuff godness, so you need to ensure that you don't have any configuration bottlenecks. So inefficiencies that you add to your build scripts that affect configuration time basically affect every Gradle invocation. So that's why it's important. One of the things that I'm also seeing is that there's no critical review of the plugins. They have inefficient configuration. They do too much stuff to configure the project, to add tasks. And this, in a large project, it adds up, and it's expensive. Now, so typically when people work on a plugin, they even have, let's say they have an integration test for that plugin, and they run this integration test, and wow, it's really fast, right? In my Hello World sample that I'm testing the plugin with, it applies in, let's say, 500 milliseconds. 500 milliseconds to apply a single plugin. Wow, that's cool. Now imagine that you have to apply that in a 1,000 project build, this single plugin. That takes 500 milliseconds to apply. So it's going to add up. Now the configuration time of everything takes 10 minutes. To do anything, to run clean, you have to wait 10 minutes until everything is configured. So it's important to ensure that the configuration is fast. Now, some of the features like configuration on demand and other things we plan will reduce that problem because not everything will be configured. Some of the stuff will be cached. So there will be other ways to fix that. But at this state of things, just ensure that configuration is fast. Some of the things that I'm also seeing is that sometimes dependency resolution happens during configuration phase, which you want to avoid. And I'm not talking about the build script resolution. I'm talking about the accidental stuff that we can do. Things like when you do, let's say, I'm going to create some task here. Task foo. And then here I'm going to do configurations, compile files. And let's say based on the files of that configuration, I want to do something. It looks, I want to configure this task or whatever. It looks, it looks tidy and small, but when you get the files property from configuration, you're going to resolve that configuration. So you're going to potentially download dependency from the web. And this is happening in the configuration phase, which means this resolution happens every time you do anything with that build. So we want to avoid that. Basically, every expensive stuff, you need to push that out to the execution phase. You don't want to do that in the configuration phase. Missing the last, my favorite problem. So let's say we want to write a hello world task. Print line, hello world. And how do we test that? We run that. Am I in project 3? Yes. Hello world. Actually, let's get rid of this Hang on. I'm gonna run it again, but I'm gonna comment out this after evaluate. Okay. I'm running the hello world. Yeah, it works. It prints hello world. It works. Like, you might not see that it's up to date and the task hasn't been really executed, but you still see hello world, and people are happy that this is working. Now, problem is that any task I'm running, like show dependencies, for example, which I should have, yeah. I don't have that task. Da-da-da. Maybe build a Gradle. Let's see what I have here. Oh, I'm going to run the dependency report task. I'm running the Gradle dependency report, but hello world is printed. Yeah. So the problem is that we missed the do last. So there's this. You need to be aware, like configuration execution, most important concept. Missing do last. Something is happening in the configuration phase where you would thought that this is all good and all working. Now, consider build scripts, Gradle build script. It's configuration. We configure stuff. We configure the hello world task. We configure it by specifying an action that gets executed when the task is invoked. So it's all configuration. Yeah. So, any questions you might have so far about that stuff? Yep.
Would you consider that the most misunderstood piece of Gradle?
Configuration. Yes.
For tasks.
For tasks.
Yeah, for I'd say my users, that's the biggest thing. They'll do tasks, the name of code, and it's just wrong case.
And it's not even most misunderstood, it's most easy mistake.
It's so missing the last. Just keep that in the back of your head, because it's going to happen in your builds somewhere. So it does not mean that you're going to do it, but you're going to find code that does it. So yeah, it's everywhere. What's up?
I just did it. I understand now why that happened. Well, I didn't just do it. It was a while ago.
Yeah. So yeah.
So, yes is the answer, and go to Adam's talk tomorrow morning.
Yeah. So Adam basically tells the story about the new features of Gradle, and the majority of his talk will be about the new configuration model stuff. Configuration and execution, you know.
But there are some type tasks that if you put the do last, it will not execute, like copy.
Yeah.
Want to copy, do it in the execution.
Yes. So, so the question was that sometimes you don't have to do the do last. Yes. So when you use the, because this is just a default task, that does nothing until you add him a do last section or do the first section. But this task here, dependency report, is a task of a specific type of a dependency report task. And this dependency report task already has an action attached. This action is coded into Java code, given that this task is implemented in Java. So this task does not need any do last thing. This task already has an action. You just need to configure this task. And we configure this task by adding the outputs, by adding the output file. Does it answer the question? So this is like a, I don't know how to call them, ad hoc task, let's say, without specific type. An ad hoc task do nothing until an action is attached to it. Hang on a sec.
With trying to build out a library of reusable plugins and parts with the community, and some of these kind of considerations with how you design plugins that are using good practices that make things reusable, that don't have all these collisions. Do you guys have ideas on how to kind of encourage better practices in the community, like maybe putting together like a peer code review kind of thing that people can help each other out or something? I was just wondering if you guys have thought about that.
So the question was about best practices of writing plugins and sort of rising the knowledge, right? And sort of broadcasting that knowledge so that everyone can take advantage of that and write good plugins, yeah? How to do that? Well, that's tough. Maybe well, yeah, it's a tough question. There's lots of things that we can do, we should do about that. Go ahead, Luke.
It's a technical issue and largely a cultural issue as well. So one of the things we want to foster around plugins.gradle.org is a very collaborative culture, that people are willing to accept contributions to plugins, and rather than somebody create their own Avro plugin, work with the original author to get that stuff in. So more best practice type stuff for plugins, but really, I think the meat of it is going to come through some social constructs.
So do you have any ideas or plans on building out social constructs that will support that?
Not much more than we want to. It's a tricky thing that none of us are expert in, so we'll be trying to find some people who have done this before. Yeah, so, no, I can't do anything concrete, but we're keenly aware of this.
We want all plugins to be beautiful and clean, so that we don't have to code that much of built-in plugins. So yeah, so I want to just quickly write something here. So this is configuring. This is executing. Right? So that it's. I just want to make sure that everyone understands that, because we've been talking a little bit about that. But so do last is an action. This thing here, whatever is here, is executed, invoked during execution. This stuff that you see, print line here, this print line this message configuring will be printed every time you do any invocation of that build, because it's during the configuration phase and we are configuring this. Make sense, or more about that? Any questions about configuring and executing? No, everyone gets it. Everyone is an expert in Gradle. Excellent, that's what I like to hear. Okay, so fast execution. To ensure the build execution is fast for your builds, big builds, small builds, you need to have a fast configuration. There's a parallel build that you want to use. Let's actually do a quick demo of a parallel build. So I have a multi-project build. I hope it's not broken, because I've been coding some stuff here. So I'm going to just run Gradle build. Let's see how long does it take. So first 100 project configured. Every single project of that build has a little bit of Java code and has a little bit of tests, so that it's kind of real and it's building. So let's see how long did it take. So how does the parallel build works? So when you do Gradle -- parallel, what's going to happen is Gradle will take a look how many CPUs are available on that machine. Let's say there are 8 cores available, and we'll create 8 worker threads, and every worker thread will be consuming some tasks to execute. One thing here is that we only allow single project, so we don't parallelize within the project. Let me explain that. If you have a single module project, okay, you won't take advantage of the parallel build at all, okay, because within the single project we don't allow any parallelism. Yeah. If you have a 2-module project and you want to invoke this build on 8 worker threads, that's not going to happen. Gradle will only execute that build using 2 worker threads, because you have only 2 projects. Make sense? Okay. The reason why we don't parallelize within the project, because there are too many thread safety issues. Too many times one task depends on the state of other task. There's just so many places in custom plugins, and there are probably places in our plugins too, that we didn't really want to get into that path. So we will offer at some point parallelization within project. Hans told that at the keynote, but not right now. We are not ready there. It's planned, but we are not ready yet. So the build took 1 minute 30 seconds. Now I'm going to run it with parallel. And I'm going to do clean first. So that build, yeah, previously I ran without clean, so the metrics might not be that. So I might not be comparing very well those things, but we should see that parallel build is much faster. So yeah, so let's take a look. I hope it's going to be 30 seconds. So I'm going to show off. We are 3 times faster. So parallel build, as well as the configuration on demand mode, we still consider them incubating features. The main reason they are incubating is because we don't have good error detection if you have coupled projects. Because like in configuration on demand, we don't allow coupled projects. In parallel build, we don't allow coupled projects. If you have some couplings, we don't break in a nice fashion saying, hey, you have a coupling in that build file. But things may not go very well. So 30 seconds, and the previous build took 1 minute 30 seconds. So it's much faster, 3 times faster when I run in parallel. Let me go to the slides really quickly. So we're going to skip that. So parallel builds. You need to have decoupled projects at execution, which is for configuration on demand mode, you need to have decoupled projects. In parallel build, you need to ensure that the projects are decoupled at the execution phase. So it's slightly different because it's slightly more lenient because typically builds are coupled, projects are coupled during the configuration phase. When you configure the build, you kind of access, you use sub-projects, for example, you introduce those couplings. Project couplings during execution phase are kind of rare. Therefore, in theory, if your project has a lot of illegal couplings, you still can probably take a full advantage of the parallel build because during execution there are no coupling. So, make sense? Yep.
What's your default thread count when you do a parallel build?
Default thread count?
8 or 10 at a time.
So default thread count for the parallel build is based on the CPUs available in your box. So on my box it's probably 8. If you go Gradle help, you can also specify that. There's a -- parallel threads, so you can specify that, trigger 4 threads. It's really cool because, like in that project, every sub-project has some tests. It has tests, right? So if you run in parallel build, those tests will be run in parallel. So project 4 tests are run in parallel to project 5 tests. Every tests are executed on the separate forked VM, so it just gets faster. And you can see it was 3 times faster than parallel build. Definitely try the parallel build, guys. So parallel build is very useful for every build. There's a good chance that even if you have some couplings, it's going to still work nicely for you because you need, yeah?
If you're running tests in parallel as well, that can interact not so nicely with this, because then there'll be some contention on the CPUs.
Not really, because when you, the question was whether there's contention on the CPUs when we invoke tests on the separate forked VM in the parallel mode. So basically, when the main process forks off a JVM for testing, the main process does not really do anything. It just consumes messages from the test VM and prints, I don't know, let's say test successful or something like that. So the main process really does not consume CPU. You see what I mean? So you're gonna have, so if you execute on 8 threads, right? What you're gonna have is you're gonna have 8. You can have a situation where you have 8 separate processes that run tests, right. Yeah. But still, the main process at that time will not going to be that busy because the JVM that runs tests is going to be busy. The main process is just consuming messages, is not consuming CPU. So we don't really see that. It works for now. Makes sense? Does it answer the question? Or your experience is different?
No, I'm expecting something different. I haven't actually tried it yet.
So it could be a problem if you have, let's say I go to project 4, yeah? And I have, in this particular project, my test task has max parallel forks equals 4, let's say. So, and then let's assume that every single project in a multi-project build configures the test to run on max parallel forks 4. So now what's going to happen, if you run the build in parallel, you might have, and let's say the build uses 8 worker threads, it means that you can have 32 test VM processes running in parallel. And that might be, that might actually be maybe worse.
Right.
So yeah, I mean, down the road, we're going to make that faster. So when you do parallel, we kind of understand that we are using 8 worker threads. We are not going to use those for, it's going to be just smarter. The parallel build will consider the settings of individual tasks so that we don't basically kill the CPU. Make sense? Right now, it's not that smart. You have to be careful, basically. When you do max parallel forks already, and you run the build in parallel, you might have too many processes. Go ahead, Luke.
You can do that yourself
Yep.
So you get this API for saying how parallel is execution.
Yep. Any questions? Yep.
I have two J's job to run Gradle build for separate projects separately. But they build this. I started to build two builds at the same time, and one build would fail because it shows that Gradle is used by other process.
So timeout, the locking issues.
Yeah.
You have two separate Gradle builds running and one locked down some resources. So, okay, so it's a question about running the Gradle processes in parallel. So in theory, now it's like, we have coded Gradle in a way you should be able to run as many Gradle builds on the same machine, even on the same project, as many Gradle builds as you want. However, we need to we need to ensure that this is reliable. So any resources that are used by those Gradle processes, for example, the dependency cache, right? Or so the local project cache where we keep the inputs and outputs, serialized information about inputs and outputs. We need to protect that. So we have added some locking mechanism, and in certain circumstances, this locking mechanism may not work ideally. So you might have a situation that one Gradle process is so busy and locks down the, let's say, dependency cache so frequently and so often that other process cannot really get that, and the other process basically will time out, saying, hey, I can't do the build because I can't access the dependency cache. So it can happen. If it happens like too often, right? Catch us at forums.gradle.org and describe the use case. Maybe there's some problem there, but generally we want Gradle to be as parallel as possible, so you should be able to run as many Gradle builds as you want. It's like, yeah, when you do parallel build and there are like 8 worker threads, and every worker thread is resolving dependencies and stuff, it might happen that a single Gradle process will be locking down the dependencies cache very often, and some other Gradle process will not be able to hit that. We don't really have a fancy mechanism to be fair in terms of, oh, this Gradle process has been using dependency cache for the past 15 seconds, so we should allow the other Gradle process to reach out to the dependency cache, right? We don't have that fancy mechanism. For now, we just, as it goes. And there are some unlucky situations where one process, especially when it's run in parallel, so it's really busy, CPU intensive, it kind of locks down the dependency cache for too long. Does it answer the question? Well, I mean, I'm not going to resolve that problem that you have, so sorry. I'm just saying that I do sort of confirm that you can see something like that given certain circumstances, but we need to find out more. So yeah, forums.gradle.org, I'm sure Peter Niederweiser will answer that, so yes. It's painful. Okay, gotcha.
Yes, because I have about 60 jobs to build. If I run them, I cannot run those builds in the same time, and they need to wait when one completes.
Yeah. So look.
Brute force way out of this problem is you give each build its own dependency cache. So you can say that this build should use that cache, and then create less contention. So there is a way out of this. If you post on forums at Gradle.org, we can get you up and running.
So yeah, So what Luke says is that you can run Gradle build with different Gradle user home, which means that the dependency cache will be different, which means that there's not going to be this locking problem that dependency cache is locked down for one Gradle process. So that's one of the ways. Although, officially, you can run as many Gradle builds as you want on a single box, even in a single project, and everything will be working perfectly fine. Yep.
But this problem has been around for some time now. It's, in continuous integration service, it's really an issue.
So with the locking of the dependency cache, which specific problem?
With the caching, the locking of the cache. On the CI servers, it is a problem, and use a separate Gradle user home.
Yeah. So one of the solutions to that problem is to implement more smartly the lock-in mechanism so that it has some fair strategy and respects and understands that there are and allocates the time to use the cache sort of in fair way so that every process gets some share. So that was one of the ways.
So to be clear, separate dependency caches is not the end of the story. That's not a solution forever. Right?
Yeah.
If you have this problem and want to solve it today,
Yeah. Okay, cool. So to do safely the parallel execution, ensure that you don't have like typical thread safety issues. So don't do mutable system properties. I've seen that problem. So build in parallel does not work correctly because some of the state in between project is shared with the system properties, and this state is mutable. So any mutable static state is not very good for safe parallel execution. So those are the standard means of thread safety. Oh, large projects in the IDE. It's not really cool. 2000 project built in IntelliJ or Eclipse. It's a nice stress for the IDE. It's not a very convenient way to work. So in general, Eclipse tend to be a little bit faster with like large builds, but has some downsides as well. For example, it's not hierarchical, and the working sets in Eclipse does not quite. I don't find it. My experience with that is not really good. In IDEA, it's a little bit better. You have project hierarchies, so large Gradle builds, easier maps to IDEA. IDEA is also fast enough, typically. So yeah, but in general, what we plan to have for large projects in the IDE is that we want to enable a clean way of working with the subset of projects. So you have a large build, but you don't work on all those 2,000 projects usually. You work on some subset of that. So we want to offer some ways so that you only import to Eclipse or IntelliJ a subset of project. So that's basically future. So we will be able to aggregate builds. We want to toggle the project and jar dependency. So in certain circumstances, a dependency can be a project dependency within the single working set, and in some circumstances it can be a jar dependency outside. So I'm sure that Adam will discuss that further tomorrow. But I have a small demo for you. Do I? Yes, I do have a small demo for you. So just before, today during the break, there was one person asking me about this kind of problem, how to work on the subset of projects. And in about 15 minutes, we crafted a small solution to that, and I want to share that. So, I'm hoping this is still working. So cd_ln. All right. So here what I have two projects, project 0 and project A. Okay, they are completely separate Gradle projects. Let me go to project 0. So this project 0 has settings.gradle, and it's a Java project. It even have a wrapper. I can do Gradle build here, and it should do stuff. Yeah, it's running some tests. There we go. And I have a very similar project A, same things. Now I want to show you something interesting. If I go to project A, it has a dependency on project alpha. I'm going to remove. So it's using the plus notation for the dynamic dependency, but don't worry about it. It's unrelated to what I want to demo it. I just want to show you that this is using some jar dependency, project 0. This is a standard notation. We have that dependency loaded into the in a local repository. That's how it's resolved. If I do Gradle dependencies here for the compile configuration, you're going to see that those are our dependencies. We also have this org project dependency. Since this is a dynamic dependency with this plus, we see that it's resolved to that version. But don't worry about it. That's not the part of the demo. Consider that as a standard dependency. Now what's happening if I cd into the upper folder, here what I'm going to do is I'm going to do Gradle project A dependencies. So I'm going to show you exactly the same, but I'm running the build from the upper folder. configuration, compile. So this dependency has been replaced by a project dependency, which is quite interesting. And the magic happens in the settings.gradle file. So again, those are, let me just, so that it's on the top. Those guys, project 0, project A, are completely isolated projects. Project A has a standard jar dependency to project 0 that is deployed to some local repository. But when I invoke the build from here, from like something that wraps those projects together, those projects between each other appear as project dependencies. How does it happen? Well, we've hacked something in the settings.gradle that I want to share really quickly. So I'm including project A and project 0. I've created a small array of those projects. Now I've added some hook here. I'm not going to explain like too much, but I just want to show you the flexibility of Gradle. If I had more time, I would just demo that from scratch. So I'm attaching a before project hook on the Gradle instance. For every project, take every configuration and every dependency. If that dependency, name of that dependency, is either project A or project 0, and this dependency is not project dependency. This is to avoid Stack Overflow. I'm going to remove that dependency, and I'm going to replace that with a project dependency. So this kind of a little hook that is introduced through the settings.gradle enables that feature, that a jar dependency is replaced with the project dependency. There you go. It's an interesting show of Gradle flexibility, where you can script your settings.gradle to enable some interesting features. But this is not a complete prescription to that problem, because if those projects are also multi-project builds, you're going to have to add more smartness here. So this is not like a complete solution, but maybe it shows you the flavor of that a little bit. Any questions for that, maybe? So there you go. With a little bit of scripting, attaching some hooks, you are able to replace a dependency at the point where this dependency is added, and replace that with a different dependency. And here we are replacing jar dependency with a project dependency. And that's generally the future of build aggregation. We want Gradle to be smart enough and figure out that certain dependencies can be internal project dependencies, but in certain occasions they can be external jar dependencies. This will enable complete flexible working environments for developers. Do you have any questions, maybe? I promised Ruth to show that last slide. Come on, give me full screen. There you go. So there you go. We are Gradleware. We are for consulting, support, and training. So any questions you might have for the large projects, for configuration, and for those things? Don't do large projects. Don't go to those presentations. Just, I should have Gradle is in small projects presentation. Like, everything is cool, guys. Go home. It's so easy in small project. Everything just works. All right. Thank you very much for attending. See you around.